So in this video we're going to talk about the concepts reliability and validity when it comes to observation and generating data. Now, reliability and validity are concepts that are common within quantitative research, but they're also important concepts within qualitative research as well. Although there is some debate around this based primarily upon disagreements, as I've explained before, in the most common kinds of philosophical assumptions and frameworks that operate within primarily quantitative and qualitative paradigms. Qualitative researchers often see themselves most commonly as coming from a more constructivist, subjectivist paradigm, whereas quantitative researchers often come from either a positivist or a critical realist paradigm. However, that's not to say that, as I've explained before, quantitative or qualitative research has to be tied to a particular philosophical paradigm. And so these concepts of reliability and validity can be important in both quantitative and qualitative research if you are interested in trying to understand whether or not the operations that you perform as part of the process of conducting your research are repeatable in the sense that they are conducted in a consistent manner and that they would generate similar results were you to do them again under the same conditions, which are key important factors to consider. And if, for example, you are interested in your observations and operations being observations of something or operations that provide empirical indicators of some construct or concept of interest in the context of your research, then the validity of them to provide that is important as well. You'll sometimes see in qualitative research, though, that terms such as truth value and consistency are used instead. But really, these mean the same sort of thing. We're interested in the repeatability of the operations we perform and the processes we go through in our research, and we're interested in whether or not the data that is generated is a valid reflection of the ideas and the abstract concepts and constructs that we're interested in investigating in the research. So, when we think about reliability and validity, we can use a simple metaphor such as throwing darts at a dartboard. So let's say, for example, we're conducting some sort of observational operation. We're trying to generate some data about something. And in this case, let's say our operation is throwing darts at the dartboard. And the thing we're trying to get is that bullseye in the middle. That's the thing we're interested in. That's the abstract concept, the construct, or it's the specific score from a given test that we're applying that we're interested in. Now, a reliable test is one which provides consistency in terms of the values that are produced or the observations that are produced, the data that are produced, when we apply that operation on repeated occasions under the same conditions or as close as we can possibly get. So reliable data is one where we see consistency in our results. So for example, the left-hand figure here would be reliable. We see that there's clustering of multiple observations within the same area. The figure on the right would also be considered reliable because they're all clustered in one part of the dartboard. However, the difference between these two is that the left-hand one here shows clustering that is nowhere near the bullseye in the middle. So this would be an operation or an observation process that we would be using that would be considered reliable, but not necessarily valid. Now, if there were systematic divergences from the true thing, concept or construct that we were interested in, and we have reliable tests, then we may be able to adjust for this. But sometimes it's tricky to understand whether that's the case because we don't always know, independent with only one method, whether or not we're really capturing validly that underlying concept or construct or true score that we're interested in. On the other hand, on the right hand side, we've got both reliable and valid operations that are being performed. So this is the ideal situation that we want in quantitative or qualitative research. The thing that we're interested in, we want to be able to know that if we were to consistently try and observe this under the same conditions, we would observe the same things, and that what we were observing was what we thought we were actually observing. Now, these two ones in the middle present situations that are not ideal. Apologies, I've just noticed there's a spelling mistake there. But in this case, we've got data that is valid, at least on average. So, for example, all of the dots are centered around the bullseye in the middle, but they're not reliable. Any given individual observation is going to be quite different from one another if we were to take repeated observations. So we can have something that is broadly speaking reliable, or at least reliable on average. Valid on average, but not necessarily reliable when we take a given individual result. So in this case, for example, we might say we're not sure of the reliability, or we know that our measurements are not reliability, but if we do it over and over and over again, then maybe the errors will wash out. In this case, though, we see we've got some systematic bias where we have values that are neither reliable, they're spread out quite far, and they're also not valid. They're not capturing truly the value because they're, on average, they would be centered somewhere away from the true value that we're interested in. So reliability, or the consistency in the qualitative nomenclature, just refers to the fact that the observations, the data that we produce, if we were to perform the same operations under the same conditions, we would get pretty similar results. We would have consistency, reliability in the data we produce. Validity is more about whether or not we are capturing the thing that we actually think we're capturing. However, it's a little bit more nuanced than that, and you will come across in the literature different kinds of validity, or at least different labels that are given to different types of what is considered to be validity. So we've discussed this idea within the nomological net from Cronbach and Mill of construct validity before, which is to say that in this case, we are happy that a operation is valid for the construct if it actually captures that concept or construct of interest. So in this case, we need to be able to have a good definition of the concept or construct of interest, and we need to be able to, in some process of logic, identify whether or not the operation we're performing meets the necessary and sufficient conditions for however we're defining this abstract concept or construct of interest. We also have what's known as content validity. Now, in content validity, we mean to what extent does the operation capture a representative sample of the domain of the concept or construct of interest. So to give you an example of this, let's say we were interested, for example, in strength of a group of individuals. And we decided that our operation we were going to perform was take a single weight, say a 50 kilogram load on the bench press, and see how many people could lift it and how many people couldn't lift it. Well, this would be, obviously, to some extent, a valid indicator of strength. The stronger individuals would be able to lift it, and the ones that were not as strong may not be able to lift it. But we would only be capturing a very small portion of the domain that the concept or construct of strength actually exists along. Some people have, low strength, some people have high strength, but there is a distribution of this concept throughout a continuum. And so in that case, we would have an operation that doesn't necessarily capture the full content of the concept or construct in the population or the sample that we're interested in. Now, we next have face validity, and face validity is similar to construct validity, but in this sense, we may not necessarily be able to logically derive whether or not our operations are construct valid by checking whether they meet the necessary and sufficient conditions contained within our concept or construct's definition within the nomological network. But at the very least, there seems to be some appearance that what we're doing seems to capture the thing we're interested in. We may have some intuition that the process that we're engaging in would appear to, capture the concept or construct of interest. Oftentimes, things like face validity are used for things like self-report scales or psychometric measures, where we have to come up with items and questions, and we have to think whether or not it seems as though they are capturing something that we're interested in. So, for example, in my area of effort, I have to think about the way in which I am conceptualizing that aspect of someone's perception or phenomenology when they're performing a task, and I have to hope that the way in which I provide instructions to them is valid and has face validity for capturing the construct that I'm interested in. Am I wording it in such a way that I might instead be leaning them towards maybe contaminating the report that they give me with the feelings of discomfort that they have, in which case the operation would not have very good face validity for effort. I would want to try and remove those sorts of things. We next have what's called criterion validity. And in criterion validity, what we're typically doing here is we have a situation where we already have a very valid measurement of, or operation, sorry, of the construct or concept that we're interested in. But maybe the operation that we perform is very, very cost prohibitive. It's very, very difficult to do. It takes time, resources, money, etc. And so what we're interested in is developing perhaps a less resource consuming method of operationalizing and capturing information about the concept or construct of interest in this case. So for example, let's say you were diagnosing some sort of injury, and the gold standard, the criterion for being able to do that, the criterion for being able to understand whether there's some sort of injury that's occurred is to take an MRI. But we know that the MRI will be incredibly costly, and there will be some, albeit small, radiation exposure for participants, and so instead we think to ourselves, well, actually what we would be interested in doing is comparing an ultrasound or maybe even palpation or something, some other operation that we would use to determine whether or not there is or is not a particular kind of injury that we're interested in, and we would then compare it to see if the results that we got agreed with the criterion method that we have, the gold standard that we have. And if they did, then we would say that it is demonstrated criterion validity or criterion agreement. Now, we also have something called concurrent validity, and concurrent validity is very similar to criterion validity, but we don't necessarily have some criterion operation. Instead, we may have a multitude of different operations, none of which we're sure are the gold standard, but all seem to agree with one another. So there's some triangulation of information that's coming across the different operational processes that we can use to generate data about the concept or construct that we're interested in. And so we would say in that case that they demonstrate concurrent validity, or at the very least they demonstrate concurrent agreement in terms of the results they provide. And last but not least, we have something called predictive validity. And predictive validity, to some extent, fits within the nomological network and construct validity, because you can think of the nomological network as also referring to the relations that concepts and constructs have with one another and observations have with one another at one point in time and at a future point in time. So with predictive validity, we would say that a tool or operation demonstrates predictive validity if a measurement we take at one time point correlates or predicts future measurements of the same concept or construct using the same operation. So for example, if we saw strong correlations between measurements before and after an intervention, where we knew that the intervention effect was relatively consistent, and then we would say that the measurements have predictive validity. We might be able to predict or see correlations between pre and post measures. So reliability and validity, truth, value and consistency, these are all important concepts, whether or not you're looking at quantitative or qualitative operations to producing data, conducting operations in the context of your research, and it's something important to consider.